Hey guys, this is Coach Brian going over 6.3 notes. 6.3 is all about classifying triangles. That's kind of the first part of the notes. And then we'll move into congruent triangles. So, to start off with, we're going to be looking at the left side of the notes here. And we can classify triangles kind of in two ways. The first way is by the sides. We can have equilateral triangles, where all three sides are the same. So if we want to, we can go ahead and define that over here. Equilateral triangle has three congruent sides. Second way, or second type of triangle by sides, is an isosceles triangle. An isosceles triangle has at least two congruent sides. And then lastly, we have a scalene triangle. And a scalene triangle has zero congruent sides. The other way that we can classify triangles is by their angles. And we know that all the angles inside of a triangle add up to 180, but we have some classifications when we have acute triangles. All right, acute triangles have an acute triangle. They have all acute angles, or we would say they have three acute angles. They are all three less than 90 degrees. All three angles are less than 90 degrees. So that's our first type. Second type is an obtuse triangle. And an obtuse triangle has one obtuse angle. So at least one angle, it can only have one, but it has one angle over 90 degrees. And by definition of the sum of triangles, if one is over 90 degrees, the other two can't possibly be over 90 degrees because then it would exceed 180. So an obtuse triangle has one obtuse angle. Our next type is our right triangle, which you're probably familiar with. A right triangle has one right angle, and it is 90 degrees. It has one 90-degree angle, so that's what you're used to seeing, where it's got a 90-degree angle. And then lastly, we've got an equiangular triangle. Equiangular, all the angles are the same. That's also known as equilateral. They're the same thing. By definition, they have three equal sides and three equal angles. We would say an equiangular, if I can fit that, equiangular triangle has three congruent angles, and all three angles equal 60 degrees. So that's where we've had triangles that have all three sides the same, and they have all three angles the same. All right. Moving along, it says to classify each triangle by its angles. And so this is something that my students in my classes had trouble with. And so you might have had trouble with it too. There's a difference between saying angle BCD and triangle BCD. So when you see angle BCD, this middle letter is the vertex. And so in our picture over here, it would actually be this angle from B to C to D. That would be angle BCD, just that 40-degree angle. But if you see the triangle BCD, it means a triangle with the corners B, C, and D, the entire thing. So it's really important to differentiate between angle and triangle. So all of these are triangles. And it wants you to classify each one by the angles, which means we're going to be using acute, obtuse, right, or equiangular. So the first triangle that we've got is ABD, which is this triangle right here that I'm shading in. Okay, ABD. So when we look at that triangle, it's got a big 112-degree angle, and then it's got this little sliver of an angle right there that is part of a bigger 90-degree angle, but is not the whole thing. It's just a little sliver of it. So the fact that we have one greater than 90-degree angle in there, 112 is greater than 90 degrees, means it is obtuse. And if you have one obtuse angle, you have an obtuse triangle. Our next triangle is BDC, which is this triangle that I'm shading in right now. BCD. All right. So BCD has not a full 90-degree angle. You see it's got most of a 90-degree angle. It's got a 40-degree angle. And then it's got an angle here that, we can't really tell what it is, but we know for sure it's less than 90, because if it was 90, this side BD would be more vertical. So we've got a 40, a less than 90, and a less than 90. Well, when all three angles are less than 90, that is an acute triangle. And then lastly, we have triangle ADC. So from A to D to C. If you look at A, it's 50 degrees. C is 40 degrees, and angle D is 90 degrees. And so altogether those equal 180, but also D is 90 degrees, which means this is a right triangle. Moving to example 3, it says classify the triangle by its angles and by its sides. By its angles and by its sides. So we're going to do both. Well, if we look at this triangle, let's start with the angles, because we already have two of them, and so we can quickly find the third one. If we have 180 total degrees in a triangle, and we know that this one angle is 54 and the other is 72, that means our missing angle X is going to be the difference of these things. So 72 plus 54 is 126, and 180 minus 126 is also 54 degrees. So that means angle X, this missing angle, is 54. And every single one of these angles is under 90 degrees, which means they are all acute, and this is an acute triangle. Now, we say pretty often, don't trust the picture, and this is one of those instances. If you remember from back in, I think, Unit 5, Day 1, when two opposite angles are congruent, that means their opposite sides are congruent. So I know it doesn't look like it, but this side of this angle and this side of this triangle are congruent. We know that because their two opposite angles are congruent. And so what that means is we have at least two sides of this triangle that are congruent. And when you have a triangle with at least two congruent sides, that makes it an isosceles triangle. Now, can a triangle be both? Or can it be more than these things? So when you have an equilateral triangle, it can be, or it is, always equiangular, and it's also always An acute triangle, because it's equiangular, all the angles are 60 degrees, and since they're all 60 degrees, it's also an acute triangle. Now, if we're looking at isosceles, that's a triangle with two equal sides, okay? An isosceles triangle could be a right triangle. A quick example right here would be a 90, 45, 45 triangle. Opposite sides are equal, so that's isosceles. It could also be equiangular, because a triangle with three equal angles also has three equal sides, and an isosceles triangle has at least two, so it could have three. It's also acute, or could be acute, like we've shown here. This one's a right, but this one's 60, 60, 60, so every angle less than 90. And then lastly, it could be obtuse. You could have a triangle with a giant obtuse angle there, and these two be equal, or at least less than 90. But if they're equal, those two sides are also congruent. And then lastly, a scalene triangle, a triangle with no equal sides, zero equal sides. Well, it could be a right triangle. Oh no, I meant to switch to my pen, sorry. It could be a right triangle. It couldn't be equiangular though. Can't be that. Could be acute. Could be obtuse. All right, so just because we're classifying by sides or angles doesn't mean that some of these categories don't cross over. Now let's look down at congruent triangles. Congruent triangles. Congruent triangles are triangles that are identical. And when we say that, and we look at some examples to prove it, you'll see what I'm talking about. Triangle ABC is congruent to DEF. If you look at these two triangles, they have matching sides that are congruent all the way around. They're congruent because of the matching marks that are on them. But not only do they have sides that are all congruent, they also have congruent angles. And again, you can tell by the marks, the fact that they all match. So they're similar and they are corresponding to each other. And so if you look up here at angle A, and then you look at the second triangle, which angle would be corresponding to angle A? And this one's pretty easy because the triangles are, the same shape, the same orientation, and it's easy to see what relates back and forth. So angle A is corresponding to angle D. And you could quickly see that B corresponds to E and C corresponds to F. And then we could also look at sides, all right? A to B, all right? This side here that I'm putting in yellow corresponds to DE. And BC that I'm putting in bright red corresponds to EF. And the hypotenuse AC that I'm putting in green corresponds to DF. And so, like I said, these are pretty easy to see because the triangles are they're rotated and they're aligned and they're very easily observed what's congruent and what's corresponding. And on this next example, we have two congruent triangles because it's given, but they are not aligned. And so sometimes it helps to redraw, or if you have multiple colors, it helps to color code everything. And so what we want to do is we want to specifically find out angle MLN. And if you look, that's going to be on this triangle. And it goes from M with L as the vertex to N. So we're trying to figure out this little angle right there that I just highlighted. And to start with that, we have to find what's corresponding to it. What's corresponding to it? Well, in the first triangle, it's angle EDF down here, but if you notice, there's no information there. There's no information. And so we don't have a whole lot to go off of right there. We do have, however, an opposite side. Okay, so we have that opposite side. And we also have, on this side, the expression x plus 15 for the angle. Okay, so that helps us out. Now, let's see what else corresponds between the two triangles. If I look at angle EFD, let me make that a little thinner so I don't block the letter. If I look at angle EFD, it's 5y, and it corresponds over here to 120. So that's pretty helpful. Okay, 5y equals 120. And then also, if I look at the hypotenuse right here, 2x plus 3 is going to equal the hypotenuse of the other triangle, which is 53. And so if you notice, those two allow me to solve for y and x. Subtract 3, divide by 2. And now that I have an x and a y, I can plug those in to find these missing things. All right, so first, x is 25, and this angle is x plus 15. So that means angle MLN is 40 degrees, and also that angle D is 40 degrees because they're corresponding in these congruent triangles. And then I also have y, and y is 24. So if I take 1.5 times 24 and I add 1.3, all right, 1.5 times 24 is 36, and 36 plus 1.3 is 37.3. So I was able to find my side length, and I was also able to find my missing angle. And now you could, if it asked for more information, you could find more information. This angle's 40, and this angle 5y is 120. And so that must mean the third angle brings that 120 and that 40 up to 180. So those smaller angles are 20. And then if it asks for a missing side or a perimeter, you could also figure out all of those things. And then lastly, we are doing a 2-column proof to prove that these two triangles are congruent. So remember, what it asks us to prove normally goes down in the bottom, and then you're building a case. You're saying, because I know 1, I know 2. Because I know 1 and 2, I know 3. Because I know 1, 2, and 3, I know 4. And so you're just kind of building up a case step by step until you can prove the final thing. And actually, a lot of this is filled in for us. And so we start off with a given that P is a right angle. Okay, that's given. Yep. M is a right angle. How do we know that? Well, it's actually also given. Now, it's not given in words over here. Oh, actually it is. But even if it wasn't right there in the first sentence, it's also in our picture. They are marked as right angles. Next, we know that since those are both right angles, all right angles are congruent. So what are the two right angles we just talked about? Well, we just talked about angle P, and we just talked about angle M. They're both right angles. That means they're congruent. And now this next one is asking us to say that angle PRQ, P to R, sorry, that was a very bad line, P to R to Q equals M to R to N. M to R, thought I switched colors right there, M to R to N. We're trying to say that these two triangles that are across from each other at an intersection are congruent, and they are because we know the definition of vertical angles. Definition of vertical angles. Now, the last thing it tells us is that N equals or is congruent to Q, and again, if this angle and this angle are equal, and these are both right, I mean, you've got 2 out of 3 that are identical on both of these, and that means their third angles must match. Third angle theorem right there. If angles 1 and 2 are congruent, then the third angles must also match. Now, on this next part, it's saying R is the midpoint. R is the midpoint of PM. So from this line to this line, R is the midpoint. And so you're like, okay, how can I know that? How can I know that? Well, let's look at the sides of the triangle. See how these two that have the 2 hash marks are equal? See how these that have the single hash mark are equal? If you have a triangle and 2 out of the 3 sides are the same between the pair, that means the third side also has to be congruent, and that would be our definition of midpoint. For 7, we could take that a step further, and we could say that PR is congruent to RM. You know what? I made a quick mistake right here. I will correct it though. Even though we used a third side to prove that this was the midpoint, it's also given right there. It's also given right there. So I didn't do a great job of reading my givens. I apologize. It's given. And then we know the definition of midpoint. Now the last two, 8 and 9, are also given. So if you look over here, we have a couple more things that are given. It tells us that P to Q and M to N are equal. So we would just say PQ is congruent to MN. And what we're doing right now is we're proving that all of the sides of this triangle are congruent. Because if all the sides are congruent and all the angles are congruent, then the triangles are congruent. We know from what we've built right here, hey, this is a right angle, that's a right angle, so the angles are equal. These two angles, the second ones, also equal each other, and so the thirds also equal each other. So between 1 and 5, we prove that all angles are congruent between the two triangles. All angles are congruent. And then from 6 to 7 to 8 to 9, we proved all the sides are congruent. And then if you've proven those two things, that all the sides are congruent and that all the angles are congruent, then you've proven by the definition of congruent triangles that the triangles are congruent. And there is just one last little part that I missed, and that is pretty important: the definition of congruent triangles. So let's bump back up and fill that in real quick. Congruent triangles are two triangles that have exactly the same shape. Not only that, they have the same size. And by that, they have the same sides and angles. Two triangles that have exactly the same shape and size, and by that means the sides and the angles. So hopefully this made a lot of sense to you, and you're able to better classify triangles and find out missing information. And good luck moving forward through your Unit 6 test review and test.